My name is Norbert Nopper, and today I will talk about the current status and the outlook of glTF. Of course, I will talk about glTF 2.0, which is the status, and the outlook will of course be something different than 2.0. You can later contact me via email or via Twitter. You see the contact details at the bottom. I will later provide the slides as a PDF format to Kathleen, and the slides will be available on the Khronos website. Okay, so what's this talk about? So I will take about 15 minutes to talk about the status glTF. I would like to make a rough overview what glTF 2.0 is at this point of time. It will be like really run through the main features. Probably I will not cover all of them. So after like 15 minutes, you will have a good overview what glTF 2.0 is currently. And the major part is the outlook. This will take about 35 minutes. There I will, or I try to make an overview what could come with a future version of glTF. And at the end, there's enough time, about 10 minutes. If you have questions, I try to answer them. In general, you can chat. Kathleen will collect all these questions, and at the ending, she will like cherry pick the questions, and I try to answer all of them.
Actually,
Okay.
there's a question mark icon in your webinar tool that you'll see, and you can just click that, and it'll go directly to our question panel.
Okay, perfect. So, yeah, I try my best. Okay. So, status glTF 2.0, what we currently have. So, as I said, you can, as I said, I'm talking about what's the current state of glTF. So what can we have? We have scene, nodes, cameras, and geometries. The people who are familiar with glTF, they know it best. For people who are new to this and maybe are watching this webinar, it's maybe a rough overview what it can do. So and it's also later important for my projections for the future of glTF. You can have multiple scenes, and we have a node hierarchy. And if you look to the right, you see this nice lamp, which is publicly available on the GitHub repository. Like technically this could be done, like in the simplest form, this could be provided as one mesh with one material with the texture atlas, but it's possible, and this makes it a little more complex of glTF to have several nodes, and you have a mesh, and you can have several primitives. That's quite important because this makes it more complex, more powerful, but also like at a later point of time, this can provide or implicitly can provide more extensions. So what's possible right now, you can do translations, you can do a quaternion rotate, you can do scaling, or you can provide a matrix to the node. And finally, if you look to the right, like the little lamp, actually the scene is really built up like this. You have this lamp, you have the pole, and you have this chain, and they're like composited with glTF to the final images on the at the top. You can have per node, you can have a mesh, but you can have multiple primitives per mesh. For the lamp, it's just one primitive, but it's possible to have several primitives. And the most examples you probably know is probably triangles, of course in a different form, like a fan or a triangle list. But it's also possible with glTF to have lines and points. Though lines and points, maybe you think about that's most important for debugging, but at this point of time, maybe you want to render point clouds, which is quite common now. It's really powerful. And finally, we have a per node camera, which can be orthographic and perspective. Okay, so what else do we have? So we have textures, materials, and animations. So regarding the textures, what's defined? We have images and samplers. So basically at this point in time, these are JPEGs and PNG, but for the future or ahead, we probably need other file formats as well to support. At this point of time in the core specification, we have the metallic roughness PBR model, which is my opinion, most of the powerful features of glTF2 to have now PBR rendering like data in your assets. The point is like with metallic roughness PBR, the same material model in a base form or like in a more sophisticated form. You see it in the Unreal Engine, or you see it in Unity or other big game engines. So basically, like you have the common parameters, like you have the base color, you have the metal information, you have the roughness information. The great thing is, and I think that's the first time possible, that you can exchange now like this kind of data between applications. And regarding, beside metallic roughness, you have the emission channel, which can be, of course, used in the metallic roughness. But if you, for example, have a different material system, you can use it there as well. We currently have like occlusion, which is also encoded there. And we have normal information. So yeah, you have normal matte, paratexel, and of course we have blending information. The reason why we decided for this is because it's the most compact form to describe the electric and metallic materials. And what else do we have? One important thing is animations. It's maybe just a little section on this page, but I don't want to spend too much time on this. But basically what is possible, we can have node animation. So to the right, I hope you see this, we have a spinning cube. So that's basically possible. Not only have not just static images, we can also have animated images. We have joints, which is really important, for example, animations like animals or persons, like you have like these kind of animations. And in the end, like it's also possible with glTF to have morphing animations. And this set, having this set is like a basic description language of glTF to describe a really, really good 3D model. And but of course, in some cases, people want to have more, and they say, okay, I need here and this feature, and that's the great thing with glTF, because it's JSON based. It's so easily to be extended, and which are currently like Khronos extensions. I'm not talking about the vendor extensions. I'm also not talking about the specific WebGL extensions. I will only talk about like generic or extension which are like for mobile, which are for desktop, which are maybe for offline rendering. So I leave out specific WebGL extensions by purpose. Okay, what else do we have? We have extension for specular glossiness PBR. So in some cases, for the electric materials, you need more data to have the index of refraction for having the data. In most cases, the metal roughness PBR model is sufficient, but in some cases, maybe you have some demands and you need the electric information, then the specular glossiness model is used. The disadvantage, if we can call it a disadvantage, is because you need an extra texture normally to compare to store this data. So finally, if you have a lot of data, and if a bandwidth or storage is critical, then this could be a key point. But of course, the quality increase. And of course, you can always convert without any loss from metal roughness to specular glossiness. But if you convert from specular glossiness to metal roughness, of course, you lose some information. Like the specular glossiness PBR material, we have it like right from start, which is I think there was a long discussion, should it be in core or not, and I cannot really remember why it's not in core, but it's there right from start. But during time, there was another demand that we just have an unlit extension. So basically, if you see at the bottom, you see a typical material probe. So to the left, we have like lighted concrete, and to the right, you see it unlit. So beside debugging, you can use this, for example, let's say you have data like point data, which already has the PBR information in it or already the lighted information in it, and you want to render out things one by one without lighting, you can use these extensions. Also, you can use this extension for example, to create a user interface where you say, I would have exactly the color and unlighted on the screen. So for that, the unlit extension is used. And basically, it's just a flag that, and it's using the base color information as the final render output. What else do we have? It's because everybody said, and this is what I also believe, glTF is the JPEG of 3D, and JPEG is also about compression. And we have compression of, and we have a texture extension. So let's first talk about the compression. We have, it's already like ratified. We have the charcoal Mac compression. It's basically, it's a library by Google. And we have, it's already as an extension in glTF, so it's possible to compress your geometry data, only the geometric data at this point of time. If you can compress something else, I will later talk about it. And in some measurements, you can get like up to 12 compression, which is really awesome. So in some cases, if you have to store the data, or you have to transfer it, or you have to stream it to somewhere, this is really critical, and this is really an awesome extension. Also, we have now, I think it's already ratified, we have the texture transform extension, which allows to apply texture metrics to the texture. The reason for this is that you can, for example, reuse textures on different surfaces, and at the bottom you see some math, and there's no offset in it, but basically with this extension it's possible to transform and rotate the texture. That's basically it. So the last slide for the status is, and which is really, 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 really awesome, is we have a large glTF ecosystem. Like 1 year ago, I think at SIGGRAPH, close before SIGGRAPH, like glTF 2.0 was announced. And there were like, of course, a few companies, but we have a big, big industry support. So if you look at this slide, and it gives you some time, it's like all the big engines have it. You have Unreal, Unity, the people from Microsoft in Office, you can use it. You can use it in Facebook. Yeah, you can have it in the free engine of the Godot engine. You can use it online. You can use it in, let's pick someone. You can use it in web-based, in Cesium, and a lot of tools. And if you look at the name, they're not just from the semiconductor industry, they're also from the automotive industry, they're from also from the film industry. And if you're familiar with all these brands, it's like really a big, really industry support. And that's, in my opinion, why glTF is the JPEG of 3D. It's like in just 1 year, like all big players are supporting glTF. Okay, this is what we have right now. And now I try to give an outlook to glTF. And what I would like to stress out is what we could have. And it's not like, I don't say it will come, and I also say maybe it should not come. And that's maybe, I want to say, like the success of glTF, in my opinion, is beside all the technical details, that all these major companies and also like the great GitHub community who are working on glTF can coordinate and can agree on something, which is finally something of glTF. So I would like to stress out, that's my personal projection in the future, what could come with glTF. So it does not have to come, maybe it will come, or maybe it should not come, but maybe in the future something different will happen. So that's very important for me to stress this out. So let's start. So the main topic with glTF is, of course, the PBR materials, like feasibly based shading. Who's driving this? It's the games industry, it's the movies industry, and in a few weeks, like mid of August, there's the SIGGRAPH 2018, and like the latest algorithm and the latest techniques and the effects actually are defined there. And it sounds like easy, yeah, let's just take the latest stuff from these engines and put it into glTF. Actually, it's not so easy, because you have to think about like these graphics is also like offline graphics, like you have like sometimes minutes to render a frame, and glTF is at this point of time, and that's one of the purpose to use it in real-time rendering. So what's possible? So what can and could come next? So the point is, everybody probably now have already heard about the principle BRDF or BSDF from Disney, which where the current glTF material model is a subset of it. So if you have looked at, if you have already like the base color and the metallic and you have the rastenet, but for example, if you look at the Blender node or if you look at other tools, there are more and really important and required parameters and effects which you want to have. For example, clear code, you want to have, if you want to have a car paint, it's like elemental that you have it. So what I think what should soon come, and that's because these algorithms are possible like in real-time rendering, but also in offline rendering, is subsurface scattering, sheen, and coating. Because it's well defined, the parameters do exist. And the point is, we just need to agree on these parameters. But the point is like really, it takes time. And also like there are several algorithms for these things. And the point is it has to be evaluated how to describe all these parameters, that it's accepted and it's compatible in all major engines. Because the success of glTF is because I think there's minimal adaptation to use it in your own engine. If people would have to rewrite their whole system, I think it would be not accepted like it is today. So it will take quite a long time to agree on these parameters and finally define it. What else? Refraction, anisotropy. And then it's getting sophisticated for real time. You see it like if you're doing offline rendering, you see it every time. It's for you just some parameters. It's well defined. But if you look at the latest research, in some cases, it's really tough to get a really, really good result on the screen. And the point is, regarding anisotropy, you come into a point where every extension implies you need something else. For example, in anisotropy, you need information about the orientation of the material, and which is like finally stored in a tangent. And then there's the question, do we have a tangent texture, like a normal texture, but then you're wasting data? Or do we just need a rotation when you say that's enough, but then it's maybe not so GPU friendly because you have to convert it. And these discussions, they take quite long. And then it's like, it's not something so simple because we want to standardize this. Okay, what else with the material? It's thin film. So if you want to have this oily thing, and if you know, for example, some effects, this is used in many game engines before. So the things what I show you have already seen in many engines, in many games. You have seen it in movies, etc. And the main art is to filter out, to extract all these effects into a standardization. So what could come as well would be thin film, which is like improving the quality of the output if this was wanted. And of course, like dynamic material layering. In some cases, of course, you can bake all the information in one texture, and you have like your base color, you have the metallic and roughness. But in some cases, it's not sufficient. You need all the information because you want to render it specifically. Maybe you want to take the information of the top layer into account, and it influences like the bottom layer. It already exists. For example, if you take a logarithmic, it's possible to have dynamic material layering, and you can export it. So this would be something what I see could come for the material. So let's try to summarize it. And I'd like, with summarization, please consider this as a suggestion or like a hint, or because if you guys go on GitHub and you say, oh, I would like to write an extension, or I would like to enhance something, it should be somehow give you a hint what you maybe could keep in mind when you're defining this. So in my opinion, at this point of time, most people are using glTF with a rasterizer. You're using them in Babylon, they're using in 3GS. It's really great to drag and drop it into the viewer and you see it, and then it's rasterized. But there's no restriction. You could also use it in a path tracer. You can import it in the future into Blender glTF file, and you can use the path tracer. And if you follow the latest news, like real-time ray tracing is coming back. So with the latest GPUs it's possible to real-time ray tracing. So please keep in mind, if you're writing extension for your materials, please make them like not just for rasterization, keep them in mind that the parameters can be used for both worlds. Okay. Also, what I would recommend that people should consider about if the data is GPU worth, is it transfer friendly? I think at the most point of time, the encoding of the data is really transfer friendly. With transfer, I mean, if you want to stream it or if you want to store it, it's really good. But if some of you guys have developed driver or using Vulkan, DirectX 12 or Metal, you sometimes know, oh, wow, I cannot just put the data one-to-one to the GPU and you have to add padding and you have to convert the data. And maybe this has to be taken in account in the future as well. And also like, think about the limits. I will take later about it. You still want to see like your glTF file, not on a render farm. Don't make your content too big. So that there are still people who want to see it on the mobile or even on embedded systems like in the automotive in your car. So, and the point is what's really making complicated to make an extension for the material is to find the common denominator. I will talk about this later again. And but I would like to finalize everything now on the material. Actually, you should not see at this point anything on the screen because at this point of time we have no lights in glTF. Of course, because we have PBR materials, it is implicitly defined. But if you but at this point of time, everybody is doing like on its own. You either have already a lighting system in your engine, or you're just currently implementing it. So which lights could come or are coming is punctual lights, or it's like, which is quite known from the old good times, from OpenGL or DirectX, where you have like ambient light, directional light, point light, and spotlight, and they will come. And if you follow the GitHub discussion, it will come quite soon. The point why it's not coming yet, it's of course a discussion. Should we have this parameter? Should it be named like this? But the punctual lights will come soon. Of course, if you're doing PBR, these lights, if you're in dark room, are really doing a good effect. But if you would like to simulate the real world, you need environment lights. And if you're currently dragging and dropping your models into Babylon, into glTF or in Cesium, they already have it in there, but it's not well defined. And people are currently working on it to define it, that at a specific point of time, you have a glTF file where like all this data is stored, with pre-filtered information of the specular part and the diffuse part. And this also implies we need cube maps, we need MIP mapping, and because some people want to do HDR rendering, we probably need a new file format support for high dynamic range ranging. So if you want to use floating points, that's at this point not defined in glTF. So only the environment lights will probably take some time to come. It's already in discussion, and like Microsoft and Adobe have already made a very good suggestion, and it's close to finalization where I think all these points come in. And finally, because the environment lights are very good for the most situations, but in some cases you need punctual lights, but they are really artificial. And there's also the possibility to have area lights, and this is probably, I think it's the latest research to have real-time area lights, and some engines already have it. And then there's the big discussion. If two engines already support area lights, but the other engines don't have it, what should we do? Should we define it? Should we skip it? Should we wait? And that's already this big discussion, because it doesn't make sense to make an extension where only one or two engines supports it. Of course, if you're just using in your game or in your engine, it's fine, but you always have to look to other engines if this makes sense or not. What else? Shadowing. It's a topic on its own, and there's so many shadowing algorithms. At this point of time, we have it's possibility to have an ambient occlusion map. So because you can have texture coordinates, you can either define it per the glTF, per primitive, or if you're doing smart, you can take a large ambient occlusion texture and use it for the whole scene. But the point is, this is probably not enough. And I think it's not yet touched, because the above lighting, they are doing they are casting shadow, and they are essential. And at this point of time, it will be probably up to the decision, up to the engine, what we'll have with shadows. And I don't know if this is wanted or not. Do we have to define shadows? Do we don't, or are saying people, no, we don't want to have it? This is up to the engine, but we have to think about it. Do we want to have it or not? And then if it goes into shadows, it goes into quality, etc., etc. So this was about the lighting in glTF. And there has been a big discussion about enhancing the animation system. I don't want to go into too much deep into it, but the point is, at this point of time, you just can animate a few elements in the system, which is sufficient. But in some cases, you want to animate more. And the point is, there are so many parameters and scalars and vectors in the glTF node graph where you would say, I would like to animate this. And for example, you would like to animate the base color, or you would like to animate an alpha channel, or you would like to animate a scale for the ambient occlusion. That's at this point not possible. And then there's the discussion. Should we have a generic everything animation, or should we have a specific animation for specific element? To understand this is like you could make a system where you could really reference like every node, every element in glTF, which maybe probably gets really complicated. Not in defining it as a specification, but it would be probably a blocker in many engines, because that's always the challenge. You define something which looks nice in JSON, we say, wow, that's the perfect solution, but then 90 or 80% of the engine don't support it, and then this extension would not be accepted and then would be dropped. Though on the other case, and what will probably come is we will have, for example, there will be a requirement, I would like to animate my camera. I would like to animate parameters of my camera. I would like to animate some parts of the base color. I think probably this will come, and that people can say, oh, in the future, I can also animate color parameters. And I'm not discussing about other interpolation systems or how the encoding could be, but this could be discussed as well. So we're in the render pipeline, and most of you guys have you have transformed your textures into linear space. You made all this calculation, and it's close to bring this final pixel on the screen. But in most cases, it's not well defined. You probably have in your engine, you have your tone mapping algorithm, and you have some post-processing, and that's a big question. There's some demand, which I will later talk about. There's a big demand that people want to have like the same output on different engines. For some people, that's maybe not so important, because if you ship your game, if you ship your application, you know exactly like the target device, you know your engine, and you're changing the values anyways. But there's a demand from the industry where people want to have they want to have the exact output. And the list above, it's just some cherry picking of effects or like topics, not the effects. But if you for example, for post-processing, you want to have depth of field or something else, this could be defined. But there's the big question, this would let glTF become very, very huge. And the point is always, do we want to have it or do we want to have it? It's because glTF is a JPEG of 3D, but then if we add all this extension, it's getting larger and larger, and it maybe becomes some different. Okay, what else could we have in glTF? Geometry. With procedural, I mean, for example, if you have a scene and you want to have sphere and cubes, you have always to store all the data. And if you have a really nice sphere and you store it, you need the normals and you need like all the detailed meshes, and it's getting quite large. And then maybe there's an idea, should we just have a procedural element where you say, I want to have a sphere with a radius, that's it. And it's up to the engine to do the rest. It's like if you know the old glut from OpenGL, you could create spheres, you could create torus, and you could create cones, and maybe it makes sense to add this to glTF. I don't know what the general opinion, but in some cases it would make sense. because you could save quite a lot of data. Displacement mapping. I think we already have it experimental in the Blender glTF exporter, and I think it has to come, and it will come also soon, where it's possible to displace the material. It's quite common used in game engines. It's used for terrain rendering. It's used for adding details to your 3D tools, and it has to come. This is where I think this has to come. And also like level of detail. Of course, there are all these vendor extensions, but we somehow have to agree on something, because probably in the future, maybe someone wants to store several level of details of your geometry. And maybe you follow the news, and I'm not talking about something which you already read on Twitter, which will probably come and will probably come for sure, because glTF is the JPEG for 3D. We need to compress that image data, and it's currently under development, and there are other people who can give you much more details about it, but it will come, and it's really required, and then it's like a lot of stuff is done. And if you followed like the latest Draco news, like which was announced yesterday, or I don't know, is actually you can compress anything with Draco. And it's also like it also makes sense because the animation is really, really big to also compress the animation data. So if I have not forgot everything until then, if you have the image compressed and we can compress the animation, I think we have already compressed everything in the glTF JSON file. But because the glTF file can get quite large, maybe we should also to consider to somehow compress the JSON data itself, because it's text, and maybe we want to think about how to compress this as well, to have a really, really compressed file format. So how should we organize glTF? If you already played around with the Blender exporter, if you tried out things, glTF files can get quite large. In most cases, it doesn't make sense. You deliver your game, you deliver your application. I don't care if it's some megabytes more or less. But think about the people who are like bringing content to the public, like Facebook, or if you want to store data on Sketchfab, but probably that because that's their business, they will not restrict it. But Facebook, I think they have to store a lot of data, and they're already right from start they're restricting the size. So in yours, the point is maybe that's no big deal, but the point is it could get quite common that like glTF files are not getting larger than 4 megabytes. Because if like glTF is so much used in Facebook, and every tool wants to have, we want to be compliant with Facebook, they're probably limiting your glTF file to 4 megabytes. I don't know if this is happening, but it could get like time after time, it's like a quasi standard that a glTF file has a specific file. At this point of time, your glTF file can be gigabytes big. And if this comes, or if not come, or sometimes you want to reuse the glTF file, maybe there will become a demand where you want to say, okay, I have now this chest, I want to have this character, and I have this lamp, and I have this table, and I don't want to import and export it again. I just want to reorganize the glTF by one. And then maybe there's the option, or we can think about to make a scene composition with glTF. So you take a glTF file and you say, I'm importing another glTF file, and I would like to use this mesh and node into my file. And because of this is finally the composition of a whole scene. And technically, this is possible. It's not difficult, but the point is, do we want this? And can we agree on something? Maybe it's not wanted because it's getting too complicated. Because then it's not the JPEG of 3D anymore. Then it's becoming the Paint Shop profile of 3D. I don't know, but it's an option we have to think about because it has a lot of advantages because you can organize your files much better. Rendering quality output. Yeah, that's one of my favorite topics. At this point of time, the ecosystem, we have a lot of tools, and that's very good. That's awesome, and wow, I think I have never experienced before. But regarding the quality, maybe I should not call it quality. There's are minor differences. And probably if you get an asset, you downloaded it from Sketchfab, you take it from TurboSquid, or you export it from Blender or 3ds Max. You say, oh, wow, import it, I adapt my parameters anyway, I'm happy. But for the non-gaming industry, this could be a no-go. Like, let's say you're using glTF in a future web shop, and you want to order like your a T-shirt, or when you want to buy like your latest leather jacket, and then it looks on the screen like you see it, and when you later get it delivered, it's not like what you see is what you get, and that can be a point. Or like some companies want to say, if I create the content, I would like to see it exactly like it is on the screen of my customer. So this is a big topic, and it's already discussed. And I think it has to be discussed that we get like some quality standard. If it's in the core or not, I don't know. Of course, with the lighting and all these parameters, we get really, really close, but we have to check if the non-game industry, if this is sufficient or not. Yeah, what the biggest deal is also like, how do we organize all these extensions? Yeah, to the right, I have listed again, only the companies who are involved, and it's already hard to agree. We're sometimes discussing half an hour just how to name a parameter, so that you just get a insight on this. And we have a huge community support. Everybody probably who's listening right now has already visited the glTF repository. Look at the issues, and it's really, really great. And it's because it's one of the Khronos standards which is not closed. It's really open. It's open to the community right from start, during development. And of course, we get a lot of feedback, a lot of great ideas. We get a lot of improvements. And the point is now, like, how do we organize this? You know, what could happen? Yeah. So do we want many small extensions? But then we need a dependency graph, because somebody is defining an anisotropy extension and implicitly needs a tangent texture, but someone else needs it as well. And then suddenly we have two extensions which are interfering, where you say you have two texture formats for tangents. So, and the point is, we don't want to get glTF to be fragmented, because if this would happen, this would be like a showstopper for glTF. And I think this is one of the biggest challenge we have to look at, that this is like somehow organized. Of course, we organized it, but because it's such a huge amount, and also I try to convince the community with this webinar that everybody of us should be responsible so that it goes into the right direction. And of course, we can have a few large extensions, and but again, how do we avoid extension overlapping and fragmentation? Because at this point of time, is glTF great. You can take it in your engine of choice and it works fine, but there will a lot of extensions come. More companies are working on this, more extensions will come, and also we don't want to stop the momentum. So that's a big question. I don't know the solution, I just want to bring it up. Also, regarding the progress of glTF, do we want to have a fast or slow progress of extensions? I don't know. Some people say, oh, it cannot be fast enough. And some people say, hey, I want to have it slow because we need time to implement it. And it does, because some people say, I want to have it as soon as possible because I want to have it in their deployment now. But for other people and companies, and it's part of their business, for them, it's really, really important that the extension is imported in many engines. And now we have to find like, how fast do we want to have another extension? How fast do we want to ratify a new extension? And finally, there's the question, when should be the next version of glTF? Do we want to have frequent, or do we not have frequent? If you follow the glTF forward, you see like I think every day there's some update, there's a new ideas, there's a new extension, the improvement, and that's great. But the point is, we have to say, when do we want to have glTF 2.1? When do we want to have GL.3.0? When is the right time? And this has to be discussed. This has to be done by the Khronos group, and this has to be done by the community. This has to be discussed by all of us. And then, if you looked at the GitHub, extending glTF is non-graphics. And at this point of time, you have geometry, you have materials, it's only graphics related. But if you go to the GitHub repository, you get close to a level description, because I think glTF is a lot of used in game engines and maybe for other applications. And people are discussing about event and triggers. So for example, if you touch something, something's happening. Because currently you have a linear animation, like the animation starts from 0 until second 5. But maybe you want to have a trigger that if something collides, something else should happen. Do we want this? And also there's a discussion about audio extension. Do we want to have video? And then there are a lot, if you think about, if you have developed scene graphs, if you are an engine or game engine developers, you know much more elements which are in a scene or level description. And then we come to a point, is then glTF becoming the MPEG of 3D. And that point is, this is my part. I have brought this this word, and I don't know if this is the right word. Maybe it should be something different. But the point is, do we want to have it? Of course, everybody is free to extend a glTF on its own. You can have your vendor extensions, etc. But the point is, keep in mind what you're doing and with who you should probably coordinate. And that this has to be coordinated, because if we add audio and video, this will have a big impact, because then we make out of glTF something total different. Okay, let's make a summary, and I made it quite quick as usual. glTF is the JPEG of 3D, in my opinion. Like all required features are available now. It's like as I said, you have the materials, you have the geometry, you can have animations, you can have skeletal animation, you can have morphing. And if you want to extend it, it can be easily done. It can be really easily done, but that's also like the challenge we are focusing, because it can be so easily done. And the point is, we have to discuss and to agree which features should come and not. The ecosystem, it's huge. It's awesome. It's, as I said, after 1 year, like all major players are supporting glTF. I think there's either they're like community efforts, or like the companies implemented by theirs. You have importers, you have exporters. Unity say they want to use it natively in glTF in the Unity engine, so it has a big impact. The quality is good, don't take me wrong. It's really 1% which needs to be fixed. It's like in some industry, you want to have pixel perfection, you want to have pixel materials. I don't want to complain about engines. It's also about our own engine. But the point is, we need somehow to define where we want to have a quality level. And finally, regarding the extension, as already mentioned, this will be the biggest challenges in my mind, to coordinate all these extensions. The point is, how there are so many ideas coming in, there are so many extensions coming in, and that we don't have like something wild going on, that we how do we organize it? Because we don't want to restrict the people. We want these extensions, but I have no clue how we should organize this. Of course, there's the 3D formats group, but the point is, if it's or what I would like to achieve with this webinar, that this is somehow self-organizing, that people are taking into account, oh, I'm doing something in the material system, I'm something doing in the geometry system, I'm doing something with animation, that maybe this extension coordination can be optimized. Okay, it's now 45 minutes, so I'm a little bit ahead, 5 minutes too early, but I think because I'm a fast talker, so we have some more time for questions. I try to answer most questions right now. Of course, I would like to say it again, like the outlook, somehow the projection, what I see, what's happening in the GitHub repository, what I see in the discussions. Again, I don't say it's come, I don't say it will come, and I don't say it should come, but it's like, it should bring up, it should make you think about glTF for the future. That was the purpose of this webinar, and I hope you enjoyed it, and I'm open for questions now. If I can't ask any, if you have a question tomorrow, of course, you can reach me by email or Twitter. And of course, at SIGGRAPH, the Khronos group have a BOF, and you can ask. A lot of people are from the 3D formats group are there in person, and you can ask the questions what I did say and what they think about. And I hope I have enriched the discussion about the future of glTF. Thank you very much.
Thanks, Norbert. So I'm going to go ahead and read out loud the questions that you sent. Before I get into that, though, I want to let you know that there's a document download tool within this webinar program, and you can download. We have the glTF 2.0 reference guide there that you can download, and we also have a flyer that has a schedule for our BOSS sessions that will be at SIGGRAPH. All right, so for the questions, one was, is there a chance that glTF will support light maps and environment maps, and also texture compression like BC or ETC?
Yeah, as I said, texture compression will come like ETC. There's a dedicated group for this. So it will come for sure. It's close to final. Environment maps, it will come. As I said, we will have environment maps. The point is, how do we encode them? And the point is, I think we should somehow have the possibility to use environment as a cube map just to have a surrounding, but also to use somehow the data for the image-based lighting. And that's currently under discussion, and this will come soon. Regarding light maps, I think it makes sense. And maybe I should have added to this, because if you want to bake the lighting information, of course you can already do it now, but it would be probably more a hack. So yes, I think I should add it to the list of extensions should come. And I think it's already discussed on the GitHub. And I see light maps for like on the section on materials or pre-baking materials, like in the section for ambient occlusion.
Thanks. Now that question was from Peter. Peter also asked, what about texture compression like BC or ETC?
Yeah, as I said, it's in this, let's say it differently, like there we have, let's take the opposite way. There's a Khronos standard which is called KTX, and there's KTX2. And you can, let's say it in advance, the compression algorithm for the textures which are defined there, they will become into glTF. So yes, it will come. If there's a compression which is maybe excluded, don't take me wrong, but it comes. It's just writing down the specification, but it will come. And it's highly required by the community and by the company, so it will come for sure.
Okay, great, thanks. This is about Blender, so I'm not sure if you can speak to it, but Peter asked, will Google's Draco Mesh compressor be added as an option in the Blender glTF exporter?
So actually, because we did something on the Blender glTF exporter, maybe some of guys don't already know, we will it's already started. We are merging the importer and the exporter for glTF, and it will be possible to have a round trip. And it will also be possible to have hookups for extensions, and it will be easier to add Draco compression. The point is, I don't know if we already have a Python Draco code. If we would have it, could be easily added. But I think at this point of time, we only have Draco for C, C++, and 3GS. I don't know if we have it for Python. If we would have it for Python, it could be easily added. That's the plan.
Okay. Dimi said, why not include de facto GLSL shader functionality? So you can attach a shader with the glTF to make it work with all the edge cases, like tangent texture.
That's a point. Because there's already extension for WebGL regarding the shaders. In my opinion, it should come, but it's a really big topic because we already discussed this regarding how do we describe this, because in my opinion, we should use like something like a node graph, which we already have like in Blender or you have in other 3D Max, and then you somehow export this node graph to glTF. Because the point is, are you using metal? Are you using SPIR-V? Are you using HLSL and then the final compilation? Are you using it on PlayStation, whatever, and you have a different point? So the point is you have always to think about glTF should be like the JPEG and has to run on all devices on platforms. And this, what you want to have, it's indeed required. And I personally, I would like to have it as well, but it has to be thought about how do we define this node graph? Because you have to define it in an abstract way. And if you do it this will be like a big effort, and maybe this is something, a topic on its own to define an abstract scene like shader graph, which could always be useful for in other topics beside glTF.
Okay, thanks. You touched on this when you discussed lights and shadows and animations about the danger of structural systems being bloated. Can you talk about what's being done to not add too much into the format? This is a question by Leonard.
So to repeat it, why not to add too much? Is that the
I
baseline?
think it's not why not. I think it's not so much why not do it. I think he's just asking, you know, what's being done to prevent bloat.
Actually, because the specification effort is taking some time, so it's happening it's not happening automatically. But of course, this has to take into account, and that's the reason why I'm doing this webinar, to make people aware that we are not bloating up glTF, because later you don't want to have a gigabyte file about the glTF. So I don't know the solution. Do we need restrictions? Do we need guidelines? But the question is good, because we have to take care about it. And what could bloat up the glTF is not just like the data in it. And if you have like all the extensions and whatever in the future, it's floating up by itself. So, and maybe this is something forward looking for 5 years, but because you have to steer that in the right direction, then actually, because you are asking this question, I think I did touch the right spot that you to make aware that this could be a problem in the future.
Thanks. And Leonard points out where your email address is not being displayed on the screen. Do you mind changing to a first slide that has your email address on it?
I have it on the first screen. Wait. I can switch back.
And also, no? A PDF of this presentation will be available on our website in a day or two.
Yeah, here's can you see the bottom line? Is it visible? Yep. I think it's visible. There's my email address, yep. And there's my Twitter account. So let's go back. Actually, as I said, like you get all the information to, you get the PDF and it will be provided on the Khronos website.
All right, Mike Bailey asks, how does glTF compare with other 3D import-export standards such as X3D and Koyata?
Yeah, I have to answer this. The point is, glTF is a transmission format. So you have to imagine glTF like PNG or JPEG. So it's really compact. There is as few information about the scene, and it's about a few information, so it's really compact and dense. Yeah. So you have to really compare to PNG or JPEG. And because with a PNG or JPEG, you have like the width and height, and you have the pixel data, and you have the color. And the glTF should and is the same. And like Collada or USDZT is more like, yeah, let's take Collada is like an import and export format where you want to go from one engine, like from one content creation tool to the other content creation tool. And for that, it's very important that a lot of information is kept and you have to transport more. And that's the reason it's not so dense, but the point is you need this information. And that, like Collada, you have to compare it like with a Photoshop file. When you have several layers, you have for each layer, the color information is kept, you have all the blending information, etc., etc. So for me, it's like USDZ and Collada is like the Paint Shop profile, and glTF is like JPEG and PNG. And I hope you got the comparison.
Okay, awesome, thanks. What about glTF adoption in the non-gaming industries such as CAD and CAM? manufacturing, etc.? And this is a question from Giorgio.
What exactly? Can you repeat the question, please?
What can you tell us about GL? Go ahead.
The point is, let's say you would like to, let's say the automotive industry, or like you have the film industry, or you have the product industry, and they have different demands for glTF. As far as I know, the non-gaming industry are using it, and they have different requirements to glTF. As I mentioned, they want to have pixel perfection. They want to have, for example, that the geometry is really at the exact place, because you may maybe do I don't say that it's happening, but maybe you're doing an instrument cluster and you want to have this pixel at that exact place because your speedometer needle is pointing in a specific direction. Or for example, you're making a product and you're selling the product and it has some material, it is some specific wood or it's some specific plastic. In a game, it doesn't matter. It doesn't matter if it's like a little bright or dark, or even like the surface or the texture is a little bit different. But like in these non-gaming industry, like that it's one-to-one, that it's like material, color, or whatever perfection is a really high demand. So they maybe don't need so much animations, but they maybe need on the material side that, for example, it's more extended the material system and so on. So of course there's a common denominator, and that's the thing what we try to coordinate, but the non-gaming industry has totally different demands what they expect from glTF. At this point of time, everything is fine, but for the future, we have to steer it into the right direction.
Okay, thanks. Here's a question asking what do we know at the moment about USD or USDZ specs? Are any key features to be matched in glTF or already in the pipeline? I do want to mention that we know that glTF is used in the geospatial industry by CCM, but what else can you tell us about it?
Yeah, I just did have a rough look at USDZ, and mainly it's driven by Pixar. And as I said, I think it's even possible to reference glTF files from USDZ. And of course, because glTF is such a compact format like PNG and JPEG, it's so easy to transfer in and transfer out, like to convert it. They're already converters. Regarding these questions, if you have time, go to the Khronos BOF, and there are a lot of guys who have made much more thoughts about USDZ. It's a subset, and I think, yeah, it's like, I see more like USDZ is could use glTF, and because you can convert it in both directions, I see no big impact. But I strongly recommend go to the Khronos BOF at the SIGGRAPH and ask these questions to the people who have really taken time into that.
All right, thanks. I have one more question. Are there any updates on the state of the texture format support, especially in regards to KTX?
I don't know if I'm allowed to say this. We will have future texture formats in the future. Like we will not just have PNG and JPEG, and as I said, maybe KTX is coming. I don't know, and then we have like, we can floating point textures or something else. So I don't know what is. Sometimes I have to mix my mind, what is already public and what is only what is non-public. But the point is, of course, different texture formats will come because we need floating point textures, in my opinion. And there will come something common. We have to, of course, to agree on something. And I don't know which format it will finally be, but because KTX is a part of Khronos, maybe there's a big chance that it could be KTX. But I don't know it.
Okay, great. All right, well, that's it for the questions. Do please download the glTF reference guide from the docs download tool there, and also the schedule for the BOS that we're having at SIGGRAPH. We're also having a networking reception after the BOS at the end of the day, where you can share a beer and have some conversation with the presenters and apply your questions to them directly. Norbert, do you have anything to say to close us out?
Yes, I would like again thank you for your time, and I hope you enjoyed it. And I hope some of you guys have the time to go to SIGGRAPH and to meet the people who created glTF, the people who implemented it. And yeah, I hope to talk to you, see you soon.